Hey everybody, welcome back from Christmas break and welcome to our 6th unit of Advanced Biology here. Today we're going to start video 45 of part of Unit 6, the cardiopulmonary system, and today we're going to be looking at the heart. So the heart obviously is not the size of your face, otherwise that would be very hard to fit in your chest. It's actually about the size of your fist and weighs less than a pound. So in humans, it's actually much smaller than you might anticipate. The bottom of the heart here kind of comes to a point, and we call that the apex. And the apex is going to be pointing towards your left hip while also resting on top of your diaphragm. The top of the heart is going to be pointing towards your right shoulder, so you can kind of draw a straight line from the right shoulder to your left hip, and then on top of the diaphragm is going to be where your heart sits. So actually, when you're putting your hand over your heart for the national anthem, Pledge of Allegiance, having it over here on this pectoralis muscle is incorrect. If you're actually trying to put your hand over your heart, you'll turn it like this. See that straight line going from my right shoulder down to my left hip, and I'll put it right there. On top of that xiphoid process, on top of the body of that sternum. That's going to be about where your heart sits. Here you can kind of see that they're pulling the lungs back to show how it's sitting on the diaphragm here. You have the apex pointing towards that left hip and some various structures that we will be going over during this unit. So on top of the heart, you have a double-walled sac. Known as the pericardium. Cardi meaning heart. It's going to be filled with serous fluid in between these two layers. And serous fluid is very, very slippery. It's very comparable to the synovial fluid that you have in your joints that we talked about during the skeletal system. But its job, you can see the question there asking why you need that serous fluid, and right here it would be located in this pericardial cavity. Basically, if you think how often your heart is beating, right about once per second, maybe a little bit more, that's a lot of heat and a lot of friction with that heart and the surrounding structures. You just move your hands back and forth like this, they heat up very, very quickly. So the purpose of that serous fluid is to make it basically a frictionless surface with the heart and all the tissues surrounding it so that there is no heat buildup as that heart is pumping. You don't overheat your heart, your lungs, and all the structures associated with them. Opening up the heart, we can see that the heart is divided into 4 chambers. You have 2 atria, or the singular atrium, and 2 ventricles, and we'll get to those here in a second. The atria are the 2 upper chambers here. They're very, very small and very thin compared to the ventricles, and their job is going to be to only receive blood. So both the right and left atria are just going to be receiving blood. The ventricles down here are going to be much bigger, and they're going to be much thicker when it comes to the heart muscle associated with them, and their job is going to be to expel or to discharge blood. You can also divide the heart up into its right and left sides, so you have a right atrium and a right ventricle, and you have a left atrium and a left ventricle here. So depending on what we're looking at here, you can divide it up into atria and ventricles, or to the right atrium and ventricle and the left atrium and ventricle. In between, when we're looking at the right and left sides, in between the right atria and the left atria, going to be right here, this little bit of heart muscle in between there is going to be known as the interatrial septum. Inter meaning between, atrial referring to the atria, and then septum is just a divider. Just like you have that nasal septum right here dividing your right and left nostrils, the interatrial septum divides the right and left atria. Then in between their ventricles, you'd have the interventricular septum dividing the right and left ventricles. Now, between the atria and the ventricles, and then with the ventricles, the rest of the body, the heart has 4 valves, 2 on the left side and 2 on the right side here. So in between the atria and the ventricle, so specifically you can say like between the right atrium and right ventricle, or between the left atrium and left ventricle, you have the AV valves, the atrioventricular valves, separating those two. On the left side is going to be the mitral valve. So you can see this right here. Maybe you're able to see it. This little brown structure in here separating the left atrium from the left ventricle. Get that out of the way there. The left atrium from the left ventricle. We have this mitral or bicuspid valve. Both of them are correct. Up to you which one you want to choose. I will use both. But that's separating the left atrium and ventricle. And then on this side here, a little bit tougher to see, is the tricuspid valve separating the right atria, the right atrium from the right ventricle here. So that is your tricuspid valve on the right side. Attached to these valves, and it's a little bit more obvious here on the mitral valve here. So you see the valve that we have here where blood is going to be able to pass through. So you can almost run your hand around through here. You can see my finger coming out here. That's where blood is going to be going from the left atrium down to the right left ventricle. But attached to them and holding those valves in place are Chordae Tendonite. They are very, very tough. They are what you'd call the heartstrings of the heart here. But their job is basically to anchor these valves to the wall or to the muscle of the heart to prevent those valves from ever breaking or becoming less efficient. So anytime you have those valves break, you have less efficiency, you have the chance, and usually it does occur if you have those issues, where blood will actually flow backwards through the heart, which becomes a very big issue when you start mixing oxygenated and deoxygenated blood. I know we haven't talked about which side of the heart is the oxygenated, which side is the deoxygenated, but any sort of mixing of that makes it very, very difficult for your body to deliver oxygen efficiently. We will eventually get to that when we start talking about blood circulation and about the physics associated with circulation. In between the ventricles and their arteries, they're a lot harder to see on this heart model, so I'll just talk about them, are the semilunar valves, or the SL valves. So each ventricle has its own artery that it's going to be discharging or expelling blood into, and preventing the backflow from those arteries into the ventricles are these SL valves. The pulmonary SL valve is going to be between the right ventricle and the pulmonary artery, again preventing that backflow. Pulmonary, we'll see, means lungs. So this is blood that's headed to the lungs, and we're preventing that blood from flowing backwards back into that right ventricle. On the left side, the left ventricle is going to empty into the aorta, and so that valve that we have in between there is known as the aortic semilunar valve. And so one thing to note now that we've talked about valves a little bit, if you think about a heartbeat, you think about that famous lubbed up sound. If you're listening to the heartbeat with a stethoscope or anything like that, that lubbed up sound is what you hear and you associate with the heart. It's not actually from the contractions of your atria and your ventricles, but actually, well, it sort of is, but that's not what the sound is being caused by. Those sounds are being caused by the AV valve slamming shut, giving you the lub sound, and then the SL valve slamming shut, giving you the dup sound. So as those atria and ventricles are contracting, the valves are closing to prevent them from forcing blood backwards. And so when they slam shut with such force that they're able to form those sounds. All right, so that is just a brief introduction to some of the anatomy of the heart when we talk about the atria, ventricles, the septa in between there, as well as the heart valves. The major part of the heart, when we're talking about the heart specifically, is going over the direction of blood flow, and so we'll be getting into that into future videos. But first, we just needed to know a little bit more about the anatomy of the heart.